All right. Okay. I think we are in streaming. We are live now. Let's give us some check directly in the chat on YouTube if you have some issue on hearing us. And welcome to our NGRome Meetup. This is the road to NGRome 2024. And I'm happy to say a big thank you to P Campus School that give us the possibility to organize the meetup. And yeah, I want to leave the word to Cristiano.
Thank you. Welcome to everybody. I'm Cristiano De Nobili. Yeah, thank you. Okay, I can put it here. So welcome to everybody. Thank you. I'm Cristiano De Nobili, and I'm the lead AI scientist at PySchool. I just want to present you PySchool, 5 minutes, and give you some context. So basically, now you are at P6 at PyCampus. PyCampus has 6 or 7 villas. Now the 7th is the last one, year-round. And this is the headquarters of PySchool, as you can read it. What is PySchool? Basically, we are super strong in winning European project and also with the European Space Agency. And in those projects, we are working on machine learning, deep learning, so artificial intelligence stuff. And we are learning this new technology, basically applying it on healthcare, climate change. So you see our European founded projects are about social and or climate impact or healthcare. So we are learning, working on this project, but at the same time, we help company, okay? So we leverage our knowledge in AI, helping company or startup solving their business pain through AI. How does it work? How we do it? Basically, 2-3 times per year, we run our School of AI program, and we are selecting worldwide brilliant engineers or scientists in AI, and we group them in a small team, and each team will work on a challenge sponsored by one of the company. And we are trying all together. Each team is coached and supervised by machine learning scientists, a senior one, like some of them are here. Then I will present you the team. And each of us is supervising one challenge, which is the project that the company or startup is sponsoring. And in the 8 weeks, we are trying to solve it. So again, we learn stuff through European and social and impactful project, and then we share and we leverage this knowledge to help companies and also train new AI experts. So this is how PySchool works. And some numbers in the since 2017, we worked on more than 100 challenges. We have a community of more than 200 fellows, so the alumni, people that were into this program, and selected among 2,000-3,000 engineers worldwide. Some of them are here. These are some fellows from the current session of the School of AI. So these are some numbers, and here is a picture of us, of PySchool team. You can meet later Marcello, Vision, then some fellow, Andrea, Mabel, so on and so forth, Cristiano, Lucia. And that's all. Just 2 information. If you are interested if you are a wannabe AI developer and you have already some development skills and you have, let's say, a basics in machine learning or deep learning, you can apply for next session through this link. We are going to maybe select you as a next for the next program. Instead, if next Friday, so after tomorrow, you want to join us again, okay, we are running here a networking and pitch event where we are going to present our latest projects, our latest challenges, and then there will be a networking event. And so you will find there many others, machine learning and AI, people interested in AI or working in AI, and it's a good opportunity to mingle your network with those guys. And again, this Friday around around this time, you are super welcome to come again. Just it's free, obviously. Just apply, just register, so we have an idea of the number. So I'm done. I will leave the floor, and again, we will be here, and if you want to talk with us about whatever is AI, machine learning, or technology, yes, feel free to ask us. Thank you.
Okay, thank you. Thank you. Thank you again, PI Campus. So we live in a few months ago, and we said see you again in June with the conference. So actually, we have defined the date. So 26 and 27 of June, we are going to have a 7th edition of NGRome. And of course, follow us in our social, because we are going to give you more updates about what's coming on with the conference. And Hermano, that is a co-organizer of the conference, is going to introduce you some big news.
Yeah. So yeah, again, mic. Okay. So guys, the big thing is that we will have few workshop. We confirmed 2 of them right now, so you can already purchase ticket for them. One is mastering NGRX signal store, and that will be directly from the people developing it. So we will have Alex and Marco. You met Marco probably in the last edition, and he will give us a full day workshop. And we will also have another workshop from Manfred on micro front-end architectures and basically DDD development techniques applied to Angular. So it's something that you should check. And the workshop will be in the days of the conference. So the other very big news is that basically for today and for other few days, so until 9th of February, we will have 20% off on the tickets. Through this discount code, and this discount code works for 10 tickets only, so you should rush, but works on all the tickets type. So you can also get the workshops tickets with that, which would be a great saving. And I think that now we can leave the stage to the speakers of today. We will have Gerhard, who is a developer evangelist, web and cloud and AI. Are his topic, and you already met him in the last conference and also in the workshop that he gave us on AI topic last time. So he will be our next speaker, and afterwards we will have Giorgio, who is a senior developer, and will give us another a ticket after a question and answer session with Gerhard. Okay, so now I'm inviting Gerhard on stage, and we will go. Do you hear us, Gerhard?
Yes, yes.
Perfect. We can hear you. So now we are just placing you on stage, and basically we will mute us so we can hear you better now. That's the location where we are. It's a wonderful villa. Few people are sitting here. So yeah, and we will show you now your slides and your picture. So yeah, the stage is yours.
Okay, thanks a lot. A lot of news coming from you. Really exciting to see how you are building not only the Angular community, but also the artificial intelligence
Yeah.
developers and also researchers. So that's pretty exciting. Okay, for today, what I've prepared is a
Do you hear me now? You hear
yes,
me?
yes.
Yeah, just give me 1 second so we can adjust the audio here.
Okay,
Otherwise, people will not hear you very well. But
no
try now.
worries.
Okay, now
Hello.
works perfect. It's okay. Thank you.
Okay. There's always some technical issues. I also had to reboot my laptop, so yeah, who knows what happens. It's always before a demo. But for today, I prepared 5 use cases around the computing, the the vision capabilities of Google Gemini. And this was, I don't know if you were following, but this was just released at the end of last year. So that's going to be my focus, and I'm going to try to inspire you so you can see how you can use these visual capabilities. So I'm Gerard Sanz, and maybe you have been at my talk, one of my talks before. I'm a Google developer expert, and I go around the world to different events sharing my learnings. So you can see that I've been doing this for a while now, and I'm always happy to engage with the NGRome community. So last year, in December, we had news coming from Google during the Applied AI Summit from Google Cloud. And basically, they released a new model, which is Gemini. And as you can see, Gemini comes with 2 products. One is Google AI Studio, and the other one from Google Cloud is Vertex AI. Today, I will show you some examples using Google AI Studio, but we don't have time to cover Vertex AI, which is the cloud platform. So let me give you an overview of today's Google AI ecosystem. So we have plenty of things, so I'm going to try to give you an overview. First, we have BART, which is one product that you can use, and it will be a chatbot experience, so you can ask questions. It will have different integrations, and I'm going to cover those a little bit later. Then we also have Google AI Studio, where it's basically a playground where you can try different prompts and see how the model behaves. Everything in Google today is powered by the foundational model called Gemini, and that includes the AI platform in Google Cloud, which is Vertex AI, and also an AI assistant, which is called Duet AI. And maybe you haven't seen some of these products, so I'm gonna try to introduce the ones that we are gonna use. Just very recently, there was a new model that was released, which is Imagen 2. And this comes within BART and also is available using Vertex AI. Here you can see an example where we can create products and also edit their visual capabilities. So here we have a bag which is green. We can edit this image that was AI generated and change it to another color. These open a lot of possibilities, and I would encourage you to try Imagen 2 either from BART or Vertex AI. There was also some other products that were released. One of them is MMXXIV, which was created by Google AI Labs. And as most of these technologies, some of them are only available in the US. So I'm using a VPN to show you these demos. So this one is a new product that is around the visual capabilities of Imagen 2, which I just show you. And I'm going to show you live. So let's see if I can get the UI. So this is how it looks. So we have On the left side, we have a place where we can add our prompts. And one of the new innovations that they introduce is these drop downs. So we can change how the visual properties, the visual features of the generation are changed. So it's a little bit easier to explore, and I'm gonna just try, I mean, never try this live, but I'm gonna try to, to change this live. Let's see what comes up. So you can see that I'm not just showing you a screenshot. So here we can see the results, hopefully. Okay. So it doesn't seem to have changed the image that much. I cannot see any differences. Let's, as always, I have other prompts to show you, and this goes around. So the first prompt that I show you was trying to display the capabilities around text, so it can render text. In my prompt, I had described Imagen2, so you can see that it was rendered properly. Another feature that it's known from image generated that was giving trouble to previous models is how these models render hands. So I wanted to show you how Imagen2, which powers Image FX, is rendering those. You can see that the quality is quite good. And this other image I just created today, I wanted to experiment with a little bit more artistic feel. And these are just some options that you can use. As I was saying, you will need a VPN, as these are only available in the US. There's also this exciting project, which is Project IDX, which is powered also by a code-based foundational model. In this case, is Code, and you can request access to the project. So here, I just wanted to show you how that works. And this is a full stack development environment where you can create your applications in the cloud. And they also have a template for Gemini. So here you can see the Gemini, just to show you some of these capabilities. I'm gonna pick the bread, and I'm gonna ask Gemini to write me a recipe. Let's see how it does. So we can see that it's streaming the output, and we can see a recipe for bread. Pretty cool. Other things that were released are gonna be hopefully inspiring you. And let's move to the next section. So Gemini, as I was explaining, is now powering BART and also Vertex AI. And this model comes in different sizes. And so far, we are using, in the demos, we are going to be using Gemini Pro, which is the version that is available in BART and Google Cloud. But we also have a smaller version that it's able to run in mobile devices, which is called Gemini Nano. And very soon, Google promised to release Gemini Ultra, which is the most powerful version. So what makes Gemini different? Gemini is a multimodal architecture. It's using a new multimodal architecture. And how that works, what we can see here is, besides text, we can also use voice, images, and video. And you can see these on the left side. And that's going to be the input of the transformer. And then as part of the output, the model can either generate images or text, or both together. So this is a new kind of architecture that goes beyond generating text, which is pretty exciting. So far, we can only use images. There's no capability to use voice or video, but this is showing how these models will look in the future. Probably Gemini Ultra is going to add some more features to the text and image support. As you can see in this picture, Gemini will be also able to generate images, which now you need a separate model like Imagen 2. So this is quite exciting because a single model is able to cover all of these different modalities. Okay, so let's try to understand how this works. Gemini, we don't have a lot of information about the architecture that is running behind the scenes. We can maybe guess that it will be an architecture similar to a visual transformer, which I use in this slide, or maybe similar to Flamingo, a previous multimodal model. And here I have an image of a cat to show you how the model processes the information. So the first thing that the model has to do is create patches that will split that image to be able to process it. And this will have different resolutions. So here I'm showing you 3 different sizes for these patches. And the patches will allow the model to focus on different regions and information and features from the input image. So here we can see different details. So as I was explaining, there are different sizes. There's one size, then the double size, and then a grid of 3 patches. And that will allow the model to capture final details or maybe different parts of the image that are important for the task at hand. If we look at the attention mechanism, which is very important for the transformer, this is going to give you another idea that how the model sees or processes the images. So here, for this cat, if we look at one of the patches, we can create what are called these attention matrices. So each of the different attentions heads can focus on different parts of the image. So you can see here 3 different heads looking at different areas on the image. This will allow this visual transformer to have very flexible capabilities, and I'm going to try to show you which are the most useful. Before I go into the visual transformer, I want to introduce you some of the computer vision tasks that and how are done today. So here, just to see the complexity behind these models, you have models that will give you a semantic segmentation. So if we give it an image, it will give us some different classes. In this case, it's going to be a cat, a grass, and tree. So these are different objects, but the link between the objects and the classes and the pixels will be specifically for semantic and segmentation tasks. So this will be a very specific task that these models are trained for. If we want other extra information, we need to create different types of models. In this one, we can get a model to give us a classification and also the bounding box. So that's going to give us that the image is a cat, but also it's going to give us in which boundaries are the cat located. So these are different tasks. Of course, when you want to treat an image from different perspectives, that's going to involve different models, and maybe you will have to try a set of these models to see which one gives you the better performance. Here, I'm showing you some other tasks like object detection and instance segmentation, and these are now working with multiple subjects. So here we have 2 cats, a dog, and a duck, and you can see that the bounding boxes now are around these different classes of objects. And then if we want to do segmentation like we did before, we can also separate the instantiation for the different subjects. As you can see, these different tasks require different capabilities, and so far we have been using these different models to achieve the best results. With Gemini, this is the first time that we have a generalist approach to computer vision, and that means that Gemini is able to do all sorts of tasks, more or less what we have seen before with ChatGPT or GPT models. We have seen that they are generalist text models, and they can do all sorts of tasks. This is the same now for computer vision, and I done a few experiments, and these are the categories that I found out that show you some of the most useful use cases. So here we have a visual chat. So one thing that we can do now is, if we give image to the model, we can engage in a conversation. So we can ask things that, what objects can you see in the image, how many of them are there, and all sorts of conversations like that. Another thing we can do is extract data. This data could come in different formats. It could be handwriting, it could be data entry, OCR, or even finding metadata from different sorts of images. We're going to see more examples. So right now, I'm just trying to introduce you to this. Another one is, of course, identifying different objects. So that will be around recognition, or maybe you just want to create a description for a picture, or maybe finding a class or a category for it. This will be used in for different tasks. So it's for now, I'm just trying to introduce the different features. Some exciting features coming from visual transformers is that they can also find not only features on the different objects and in different details, but also it can find structure and relationships between those. So it can go farther, and it can also do what is called tracking, or maybe you can find out what activity is the picture representing. This introduces more capabilities. There's also 3D and 4D, which introduces time. So you can show it a series of pictures, or maybe even a video, and it can tell you what happened during those different pictures. So very, very exciting. Of course, one thing that happens when you are facing a generalist visual transformer is that you need to explore what capabilities can do, and it's not clear what these capabilities can get done. So there's a lot of exploration. Some of the use cases that people have found useful for is, for example, the OCR for evaluating exams, for example. So you can get an exam that mixes characters with handwritten messages, and it can try to solve problems or verify the 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 solution for a problem. Other thing is, for example, for e-commerce, it can identify different garments or clothes, and if you provide a database, it can find those products for you. Of course, it has support for multi-language, so that's also another industry where you can use it for travel or entertainment. And then, of course, when you are studying, it can also support studying by recognizing. In this example, is a flower, but it can also recognize animals or historical artifacts. So these are pretty exciting for itself. Let me show you some of the most common usages. So of course, one of the first use cases is just providing a description or a caption for an image, and you can use it in this way. So here I can just give it a butterfly image, and it will give me a description of what is in. You could use this, for example, to create, to automatically filter or add a large number of images into a catalog, or you can also use it to classify products for an e-commerce site. If we explore more into this chat experience, what we will see is that we can follow this visual question answer format, and we can ask all sorts of questions. So here I'm asking, what is the color of the left fish? So it knows to differentiate sides in the picture, how the space is set up, and also find features from the different subjects. Here it gives me two answers. It gives me a blue, and also with a little bit more detail, blue, white, and red. Of course, because it's a conversation, you can ask more details and follow up on that. I show you the most easy to see applications. Let's try to show you a more complex one. So here is a multimodal example. I'm giving the model a text and also an image. And this is from my time in Barcelona. So the language in this picture is Catalan. And we have a schedule for a shop. And we can see that the schedule has been written over with some more details. So now we have the complexity of recognizing the text, but also recognizing the text mixed with handwritten details. So here I'm going to use this prompt, extract the text from the opening hours and consolidate them in a single paragraph in English. So I want the model to translate this into an English message, and that's the result. So it's giving me Monday to Friday from 6:30 to 1, and then from 4:30 to 8. If we look at the message, I can tell you that that's correct. I'm not sure if from your Italian perspective you can read Catalan, but that's exactly what it says there. Let's see what happened behind the scenes, because when you see an example like this, you may miss into some of the details that are happening behind, which show the power of Gemini. So the first thing that is happening is that we are applying OCR. And OCR, as you can see, it has direction. So it needs to read the text on the right order from left to right. And also it needs to find the different lines for this text. So it finds the beginning of the text, which translates in raw data. And that's the first step. The problem here is now we also have handwritten text, which is following the OCR text. And this is when things get a little bit more interesting, because now the model is reading the handwritten text, but still we have like these two pieces of information. It needs to consolidate this. So the next step that the model has to do is reason. It needs to piece the different information which don't make up for a full schedule, and it needs to find out that actually these were following one to the other, and it make a whole schedule. Of course, that's not the whole thing, because it still needs to translate that into English from Catalan. So there's still another step, which is the translation into English. As you can see, it has also changed the capital letters, which were following the actual sign. So this shows how flexible and how capable Gemini really is. Okay, I hope that was impressive for you. AI Studio, let me introduce you now the tools that you can use to do these examples. So that's the playground where you can run these prompts. And you can see here an example. Unfortunately, this is only available in the US. And these are the use cases that I prepare for today. So let's open this here. And let's experience the different use cases. So the first one is going to be looking into expense assistant. So it's going to take some images from receipts, and it's going to generate some information in a JSON format. So here I'm saying extract a JSON object. I'm providing the fields date, total, and currency. I'm also providing what time or what type of currency I won as a result. And I'm just going to run it. Just remember that you need a VPN access. And this is the outcome. If we look, we can see that again, we have different types of OCR. We have handwritten OCR because in the US you leave a tip, and because of the tip we have both OCR and also handwritten OCR. So that's the correct information, and you can imagine this working on a company's internal application, or you could also offer this as a service. If we go back here, I'm going to show you another example, and this one is for an e-commerce application. And I'm going to provide, in this case, just one image, but you can provide a series of images. And I'm asking, in this example, I'm asking Gemini to caption this new product also as a JSON object. And I'm providing a little bit more details. As you can imagine, the inputs or the context, it can grow for now up to 12,000 tokens. So you can include all sorts of information here. One of the main things that you use while using e-commerce is what it's called facets. And this is how the different products are organized in a hierarchy. So here I'm adding some information. You could use a query. You could create this information automatically from different API calls and get the results. You can use also this on a UI. So when a person, for example, in Amazon is adding a new product, they can get some of this information fill in from them. And you can make sure that the information, for example, for the facets, it's coming from the values that you want for them to use. So it's pretty exciting. You can mix all sorts of information, and Gemini is usually able to figure it out. Of course, you will have to go through different tests and verifications. Let me show you yet another one. So here we have, this one is around fashion. And I think this could be also an interesting example. So for here, I'm just asking Gemini to describe the outfit with the more salient features, and is finding out that it's using a necklace, a bracelet, and also is finding out where these are used in the right side or the left side. Very basic features, but nonetheless very useful. And it's giving you a general feel of the look. So this is a casual look, and when it's good to use. You can imagine this for an application that will help users to change their style in different ways, and you could provide them with the option to include one picture only, or maybe a few pictures, to try to help define the outlook that they are looking for. All right, let's move on to the next one. This next one, it's around rental cars. And okay, somehow it didn't work. Let's try this and get a little bit more space. So for this example, you can imagine someone that a service that it's renting cars at the airport, and they constantly have clients returning their cars with some scratches and going through report damages process. So of course, companies try to make this as easy as possible. And one way that you could use Gemini is, as you can see from this image, is you can provide different pictures of the surroundings of the car. Gemini is able to take up to 32 images to a size of 4 megabytes. So you could provide like a nice information around the damages, or if you are taking into a new car, you could take pictures just in case that the company is gonna make you liable for some damages that you didn't cause. So here you can see that Gemini is able to find what is wrong with the picture and also describe the damages for you and locate the damages in the car. Okay. The last example includes this visual temporal reasoning. And this is quite interesting because it gives you a sense of the capabilities of Gemini. Let me run this one. In this example, I'm using a before and after picture, and you can see how the model finds that there is a new object in the environment, and it can place it spatially. So this is very interesting. You could be using this for security. You could use CCTV images. You could use this to track a farm, to track animals, or to track, for example, production or around quality processes. Of course, you need to be mindful. Depending on the patches, you need to provide high quality pictures, and the smallest patch is 16 pixels for 16 pixels. So that would be kind of a limit of what details Gemini can find, but these are all potential candidates for use cases. I I want to show you some other things that I found during this time. And for example, I can show you a couple of examples more, and I wanted to use an image from Rome. And this is a way of showing you a very basic feature of taking a picture and trying to put it in a catalog. So you will try to find out the categories, add some taggings, and also a description. Of course, the nice thing about Google Gemini is that it can do this for you. So you don't have to actually go through the pictures. At this time, we know that there's some hallucinations, the same as we experience with text. So this is not foolproof. So you will have to verify the information at some point. And finally, this is some interesting thing. And you would think that a model like Gemini could fail this test. This is called the mirror test, and it goes around these features of a scene reasoning. So we find a picture of a dog, and the dog is reflected. So actually, if you think about how these models would work before in computer vision, the model will find that there are two dogs in the picture, but it won't find out that the dogs is just one dog looking at itself on the mirror. But if we run this with Gemini, Gemini is able to reason, and from the features in the picture, it can tell you that there is just one dog, which is looking into a mirror. Okay, I don't think we have much time. Let me just wrap up and open for some questions. If we want to use this with Angular, it will work in this way. You have access to Google AI SDK, or you can also use the REST API. The main thing that you will need is an API key that you can get from Google AI Studio, and then that will give you access to Gemini. If you want to try this, you will need the VPN access because this is US only, but this is a GitHub project that you can use to try what we have seen today. And that's all. So that's all from my side. If you have any questions, I'll be happy to answer. All right. That's all from me.
Yeah. So there is any questions going around? No? Yeah, one question. Go ahead. O la dice Emilia, la dice.
Thank you. What are exactly the limits on Gemini in terms of, we talk about tokens, the limits on tokens, and maybe you said something about the megabytes of the images. There are some other limits in terms of how many images, how big the images are, and so on.
So the thing is, of course, you could. There's some limits, like any other API. There's some limits, and it depends what API are you using. So if you are using Google AI SDK, you will have some limits. If you are using Vertex AI, you will have other limits applying. What I would say is that some of these use cases are quite exploratory. So these are very much on the research stage. I wouldn't go and use these in any projects just yet. These are very recent. Somehow in AI we have seen a lot of progress, and of course when we look at the different limitations from the APIs, you can go around them. So one thing that you could do, maybe more images because of these limits that I was mentioning, is running some pre-processing. And that's also another option to improve the quality. So you could, for example, annotate the images or maybe clip the images. So instead of using the whole image, you would use another model to clip the image down to the part that you are more interested. So there's ways that you can improve that. Of course, you can change the quality of the image to the point that the model starts giving you trouble. So you can also change that. So there's, because these are images, we know that we can change different parameters of the image without changing the behavior. One of the tests that I did is in pixelated images, and I use pixelated images of Barack Obama, and maybe I can show you. I mean, you can see how much these models can take in terms of uh, quality of the image. So it can give you a little bit of a sense of how far you can take this. But in this example, I try like really low quality images, and yeah, it worked in these tests. It works. So you can see, I don't know if you can see the quality.
Yeah, quite low.
So this work. Let's run it again. Let's see if it changes the results. So yeah, the answers are correct. So yeah, you can see also the speed is quite good. So yeah, these are things that you need to try by yourself, and because these models can change quite from task to task, you will always have to do like some tests around what is the resolution, how much data you are passing to the model, and then of course you will be doing that few times and see what the quality of the results are for your use case. But this is very much like you need to test quite a lot for now.
Yeah. Is there any other question from here? No. I do have one. Very
Okay.
briefly. Yeah. I mean, big topic is validation, of course, right? So we need to try and find ways to validate results.
Sure.
What's your experience with that? Do you have any pointers on something relevant in the validation?
So in this field, that will be named as grounding, or in text-based models, that will be also fact-checking. Or you can also use other approaches, like you could maybe try to do Google search, and then try to match the answer with some resource or some source for that same information. For visual use cases, you will have to do some, you can do like a randomized check. Of course, it depends on the volumes. I don't
Yeah, of
know.
course.
Without talking about one specific use case, it's not easy to generalize. But of course, as we have seen also with text-based models, you will have to add this layer to avoid hallucinations. And these are exactly the same model. So it's a visual transformer, but it still is a transformer. So it will have hallucinations. And I wouldn't deploy any system without fact checking or some kind of grounding. So
No, of
obviously
course.
you need to test whatever task you want to apply for a use case, but then you need to keep monitoring, and that's mainly one of the things that you can see in generative AI solutions, is that you cannot just deploy it and forget about it, because you need to introduce monitoring and also user feedback. Otherwise, the models, if they go off rails, that can be a big problem. Or if imagine you have a customer that is using your model for different purposes, you will
Yeah,
never
sure.
know. You will
Yeah,
never
yeah.
know if you are not monitoring that. So yeah, there's few things to take into account.
Yeah, thank you for that. And I think that's all for now. So we will move to the next speaker. So thank you again for being with us. And
No
it was a
worries.
real pleasure. Thank you.
Thank you.
Okay. Giorgio. Hello.
Thank you.
Yeah.
So, can you hear me? From the chat, a feedback. In case, just tell us. Okay. So, thanks to be here. I'm happy to be here as well. A little introduction by myself. I'm Giorgio Galassi. I'm a senior front-end developer working on NGRome. Today, we are going to talk about dependency injection and design pattern. As you can see from the slide, is a part one, because I would like to do such a journey, starting from the dependency injection till the design patterns. Because I think the design patterns are something that I don't see addressed too much in the front-end community. But to understand how a design pattern works, we need to understand a bunch of stuff before. So we will start with the dependency injection today. The first question is, what is the dependency injection? The dependency injection, this is a brief definition, is basically a process that will help us to improve the maintainability, the scalability of our code, and promotes the inversion of control. The inversion of control means that the control of the dependencies is not on us. Sorry. The dependency is the control of the dependencies is not on us. It's on the framework or on the container. And we will see in detail how it works in general, and then on Angular. Okay, we have some actors that are playing and helping us achieving the dependency injection. And the most important are those three. The first, of course, is the dependency, the one that we are asking to the injector. That is the most important actor, and we will see in detail how it works. Then we have the client, which maybe for the only time in our developer life, it's us. We can ask a dependency, and we will receive something in return. From who? From the injector. The injector will search for a specific dependency, for an instance of this dependency, and if it exists, we will get it. The injector acts as an intermediate layer between, again, us, the client, and the dependency that we are asking. So how the dependency injection works? In a nutshell, it's like this. The injector will find an instance and will inject it. So we will be able to use all the functionality within the class. This is a more serious example of how the injector is, basically. You can imagine the injector as a bus, as a container, where all the instances of different services are living in. Then we have our component that, in this case, using the constructor, is asking for a specific instance. We are seeing here my service, and the injector is providing us with the instance of the my service. Okay, of course, if we are going to use this approach, we want to have some advantages, otherwise it makes no sense. We have, of course, some advantages, and the first of them is the modularity. We are able to separate and segregate different pieces of code within a single class, which is the S of the solid principles. During the other parts that hopefully I will do in the future, we will see all the other letters of the solid principles. The first one is the S, as I was saying, which is the single responsibility. Means that a class should change for one reason only, and therefore means that the class has only one job. And of course, this is modularity. The second point is the testing. That I don't know how many of us are used to test our code, but using the dependency injection make it actually a little bit easier. Because if the class is small, it's easier to test, it's easier to mock, and it's easier to substitute at runtime during our testing phase. The third advantage is the readability and maintainability. Of course, if the class, again, is smaller, there is less code to check, less code to read, and it's easier to present also to others if they are newcomers in a project. So having a smaller class that only do one specific job, it's always better. Now, of course, we are speaking about Angular, and then we are going to see how it's working inside of Angular. Let's start with the basics of the basic. We have a class. In this case, we have a service, my awesome service, and we need to tell Angular that this class, at some point in time during our development, will be injected. We can do it just by adding the @injectable annotation on top. And that's it. Angular knows that at some point, this class can be injected. Now, the next question is, okay, I've created a service. I told Angular that this can be injected. How can I inject it? From Angular 14, we have two options. The old one, the stinky one, the constructor way, in which we have just to list the dependencies that we want our component to use. In this case, we are just creating a private variable that is of type my awesome service. Angular will understand that, okay, this component is asking for this instance, for an instance of this class, and will get it. From Angular 14, as I was saying, we have a new way of injecting classes. We have the inject function, which has a lot of advantages, and we will see some of them in the next parts, especially when we are talking about inheritance and other stuff. We are just telling Angular, inject this class. The type here is automatically inferred, so you don't need to actually type your variable. There is no need. It's the inject function that will understand the type of this class and will assign the same type to the service variable. Now, every time we inject a service, we have two options. We can decide that this service behaves as a singleton, so we have just one instance across the whole application. And then we can do the otherwise. So we have one instance every time the service is used or it's called. In this case, in Angular, when a component is instantiated. This is called sandboxing. So on the bottom right, we can see a component that within is at component annotation provides my awesome service. This means that every time we instantiate an awesome component, a new instance of this service is created, and the component can play only with this instance. Let's imagine, for example, a card, and we want to calculate something in this card. We want to be sure that the element that we are doing the calculation with are the elements from this card. So it's easier to do in such a way. Then we have two ways to declare a singleton. The first one, on the top left, we just need to provide our service in the providers array of the app config, and then provide this app config to the Bootstrap application function. That's it. This service will be available everywhere. Then we have another option that is using the providing property within the @injectable annotation and setting it specifically to root. We will have this service available in the root injector. There is an advantage of using the second one. Here we are seeing again the sandboxing for reference, and the other card talks about the tree shaking. The tree shaking is a process that Angular does every time we do a build and removes the code that is unused, something that is there but is not used anywhere else. This process happens for the services only if we set the providing root property. Otherwise, Angular can't understand where it's used and where it's not. Okay, so when we ask for a dependency from our component, what is actually happening behind the scenes? Oh. Before going in deep on what is happening, we need to add two more actors to this film. The first one is the environment injector, and the second one is the element injector. They works both as an hierarchy, so there is a bottom to up hierarchy, and we can add services in these two hierarchies just by, in the first one, the environment, that by the name is the injector of the whole application, setting the injectable providing root property or providers array from the application config. This will be available everywhere in the application. The element hierarchy is basically the sandboxing that we saw before. So we are going to have a single instance of our specific service within the element injector of each component, just by using the providers array from the directive or the component annotation. Let's go a little bit deeper again on how the environment injector works. We have two of them. The first one is the root environment injector, that it, basically what we said before, is where the instance of a service is global. It can be used by everywhere. Then Angular creates another one, that is the platform environment injector. It behaves exactly the same as the root, with only one use case. The use case in which behaves different is when we have more than one Angular application running in the same browser. Let's, for example, say that we have a master detail application where the master is an application and the detail is another application for whatever reason. If we want a service to be available for both of the application, the service must be provided in this environment injector, using the provide in platform instead of the root. Then Angular will search for an instance in this root injector, in the platform injector. If it's not able to find anything, it will fall back to the null injector, and we will see this beautiful error. That is the error that every one of us saw at least 100 times, maybe 100 times. And the null injector is the responsible of this error. So after you blame yourself, you can blame the null injector for this error. Okay, From Angular 17, we are actually able to have a better look of this situation. If you install the Angular developer tools on Chrome and open the tab that now you should have on your DevTools, you now have this injector tree tab. The injector tree tab is actually what it does is showing graphically how the injector are based in the hierarchy. And you can also check, this is a little spoiler of what we are going to see later, you can also check all the providers that are within this injector. And if we search, we can see here my awesome service. That is the service that in the application that is running right now is provided in the root injector. You can see also here the components that are part of the DOM that you can see on the left. So this is pretty new. It came out with Angular 17. It's pretty useful, especially if you have a big application and you want to be sure that an instance of a service is where you want it to be. So migrate your application and install the extension. It's very cool. Okay, this is the flow that Angular does every time we ask for an instance of a service. Let's imagine we are starting from the child component where we have this little injection icon. So the child component is asking for a dependency. Angular, what you will do? You will check, first of all, in the element injector. So it will say, okay, do I have this service here? I'm in a sandboxing context, more or less. If so, I will provide this instance. Otherwise, I will go back to the child, step up to the parent, and search in the element injector of the parent. And Angular will perform this search over and over again until he found something, or he will fall back to the null injector. In case he doesn't find anything, from the last element injector, we'll go back, go to the child, and from the child, we can see another arrow that is going to the root environment injector, and the search begins again. Root environment, platform environment, null injector, and throw an error. This is the flow that Angular does every time. So starting from the child, element injector of the component that are in the DOM tree, so bottom up. If I found something, I will provide it. Otherwise, I will move to the global environment injector. If it's there, it's okay. Otherwise, again, error. One question that may arise after we understood how Angular search for a dependency is, can we control it? Can we say to Angular how we can search for a dependency? The answer is yes. We can control this flow using the resolution modifiers. We actually have three categories of the resolution modifier. The first category is where say to Angular what it needs to do when a service has not been found. And we have only one resolution modifier, which is the optional. We are just telling Angular, okay, if you don't find this instance, don't care. For me, it's optional. I don't use it. I may not use it. One thing that is important to understand here is that the optional will guard us from the console error and from breaking our application. It will not guard us against the check in our code. So if you want to check and use the service, you have to check it for it. What? Check, yeah. If service exists, then I will use it. Because from experience, if the optional don't find anything, the value of the service is null. I mean, if Angular don't find anything and we have the optional annotation, the value is null. Then we have a category where we can say where to start looking for a specific service. Even here, we have just one annotation, which is the skip self. So we are telling Angular, okay, I'm asking for a service, but don't check in my element injector. Just start from my parent. and is actually what it does. So you will start from the element injector of the parent. Then the last one is where to stop looking. The host and the self are the two resolution modifiers in this category, and they act very similarly, but the key difference is just one. The host is used to mark where to stop looking. So if we have, let's image, a 3 or 4 child component, all inside of another, and we mark the middle one as an host, the search will stop here. Angular doesn't care if there is a service above that, it stops here. The self stops at the component that is asking for that specific service. If the component has that service, it's fine, otherwise, error. In fact, we can combine everything here, apart, of course, host and self and skip self. We can combine everything. The most common combination is if you're going to use host and optional, self and optional. Because in a more complex scenario, maybe you have a directive that you want to place in top of a component that maybe is injecting a provider. So that is optional, and you want it only in the host, in the directive. There are rare cases, I understand it. In my experience, I've used self and optional, and maybe one time the skip self. So the use case has to be very complex, or we want to be very, very able to configure everything in our application. But it's good to know that those are actually some options that we have. Okay, we can see really fast. We have an example on the left where we are just showing a group of components, and you can see on the bottom right how is the hierarchy. So we have the app component that then inside has my awesome parent component, we have another component, and then we have the last one, which is the child. Every component is showing on the UI this root prefix. This root prefix actually comes from a service that is the one that we saw before in the root injector. Bella domanda. Okay. So this is the service that we saw before in the root element injector, and we are just saying prefix root. All the components are just just showing the prefix in the HTML. Every component does the same. We have the app component, the parent component, and another component in the middle. Okay, let's say that we want our component to search, to mark this as a host. Using the inject function, we can configure the resolution modifier in this way as an object. So we have all the options here in this object. Seeing host here, you see that the UI is changed because we are receiving an error from the null injector. Why? Because now the MyAwesome component is searching for a service. This is the last point in which we can check for this service. The service is not provided, and therefore we are receiving an error. In this case, we have two options. We can go with the optional. And as I was saying, Angular is telling that the service can be null, so we have to check it, to check for it. In this case, we can use a simple safe operator. Going back, we see that all the providers are working, all the components are working, except for my awesome component. Because we set the host true, and we don't have anything, and the optional to true. Now, let's say that we want to provide something in this component, and we are saying that the prefix, in this case, is my awesome component. Here we can see that from this component, and below, we have the same prefix. From this component excluded and above, we have the root prefix. So we are actually demonstrating part of the sandbox and part of the global, because this is the provided that has been provided on the global level, while here we have another instance. In fact, if we go here and we go to my awesome component, we have my awesome service listed here, because we are listing it here. We can do the same thing with my awesome child using the other operator. We can say self here. So we are telling Angular to search only in the element injector of this component, which is basically the provider's array of this component. Same thing, another error, because the service is not there. So we can go, same thing, we can go optional, check for it, and it will work. No prefix for sure, but it will work. Here we can say again, let's add something, another prefix, and now we have a prefix here and a prefix here. Again, this is the sandboxing. Let's see the last one, the skip self. So now we are telling Angular, okay, if I have an instance, even if I have an instance, skip myself, don't use mine. In fact, we are seeing the prefix from the instance above. Even if this is listed, it's completely ignored. So Angular just skip for it, go up in the tree, find something, and use that one. We can try and remove this. Now we should receive an error. Of course, we have not, because we have the optional here, but the awesome component is broken now. Why? Because we have set here the host. So this is the last one in which Angular will search for. If we remove everything here, we are seeing again root, because the child is skipping himself. The awesome component doesn't have anything. The parent component doesn't have any commented out. The app component, same thing. So we are back into the root. If I turn this off just by removing it, everything is root except for my child, because now it's checking for the provider instance that is in on element injector. So, consideration and conclusion. We saw a bunch of stuff today. We see the dependency injection, how it works, how we can tell Angular where to search for an instance, different type of injectors, the resolution modifier that we just saw, and how the resolution modifier works. So how we can able to change the flow that Angular does every time we ask for a dependency. And this is pretty much it. The part 2 will cover something like the view providers, that are another way of providing a provider using the DOM tree instead of the element injector in another way. We will see how the use value, use class, use factory will work, and probably we will introduce the first of the design patterns that we are going to cover in this journey. So for sure, part 2, maybe part 3 will come. Thanks a lot. Of course, if you have any question, I'm here. Otherwise, while we are eating. Sì.
So, if I'm not mistaken, you told us you had to use the resolution modifiers, even if it's a rare case. Since it's difficult for me to imagine a use case for this, can you tell us of, one time you had a problem and how this solved it for you?
In my experience, the use case was actually, we had an application that was an hybrid one. So we need to build the web, Android and iOS. And we had a service that was the job of the service was to store the properties. So on web, we are using the local storage, and on device, we were using the SQLite, the plugin of the SQLite. We want to use just one service to control when we use a type of storage and where and what we want to set. So we created two services, two classes, to handle the local storage and to handle the SQLite. And then we created a third one that was able to switch between the instances and set in the instances that we want. The problem here is that if you are on the web, you don't have the SQLite, because of course it's working only on device. So in that case, we wanted to be sure to set the optional for that case, and we marked it as a host just to be sure that you would go up to the root hierarchy. Because if we are on device, the local storage, I mean, the SQLite would have been created as an instance, and therefore we can use it. But since it's optional, even if you are on web, we can still use the same service without breaking anything. So this was the use case. But the use case came up only because we wanted to have just one service to control everything. Otherwise, you can check. We were working on Ionic, so you could also check the instance of your application where it is running. If I'm on device, then I could use the SQLite. Otherwise, I could use the local storage. But we wanted to have more control, and we want to avoid check for the platform itself.
When is useful to use provided in any and not root? Do you have any situation when we use it?
No, honestly, no. You have?
Yeah.
Why?
So sometimes you want to share some data in some part of the application, but not among all components. So imagine a service that is sharing data, all right? Each instance, of course, will have different data because you can instance it multiple times. So if you provide that in root, that would be a single instance. Otherwise, you can control now that you have multiple instances. If you provide that in several modules or in different modules. So it's a way you can have to actually instantiate multiple times the same service without sharing the data, of course, because it's different instances.
Why you don't use different dependencies or injection?
I mean, because that's the same service, actually. What? In che senso? Okay. So sorry for the people at home. So the question is why there is any reason to use provided in instead of provided in root, basically, if there is an example for that. And basically, in my experience, we had cases where we wanted to have multiple instances provided in different modules of the same service, of course. And that's the reason why we had to specify where we want to provide them instead of root. But I agree that in most of cases provided in root is the default and the way you go, and it's basically fine. Yeah.
Thank you. Okay, I think we are done. You have to say something more?
I think we can close.